Okay, so this is the problem we've been solving. We have a projectile. It's launched at 50 meters per second. It's launched at an angle of 36.86 degrees, which makes it a general projectile. And so the projectile is launched at an angle, so as it moves through the air, it's moving horizontally at the same time it's moving vertically. And so we need to find the initial velocity of the projectile horizontally and vertically. And so we already talked about this. The initial velocity horizontally is the initial velocity times the cosine of the angle, which for this problem is 40 meters per second. So the ball is moving 40 meters per second to the right at the beginning. It's also moving 30 meters per second upwards. So it's not only moving over to the right, it's moving upwards. And so you can solve this problem, and we already solved it a couple times. You can find the time that it's in the air. It's 6.12 seconds. That's how long it's in the air. And you can find the range. It's 245 meters. Because after you know the time, of course, you can solve the x problem for the distance it goes. So what we're going to ask today is a new question. It is, how high does the projectile go? How high is it when it reaches its highest point right here? So that is what we're interested in, the maximum height of the projectile. So we're talking about this point right here. Now, we found a time of 6.12 seconds when we solved this problem. We cannot use that time because that is the time the projectile reaches the ground. That's not the time it was there. So although we already found the time, we can't use that right now. So that's why I'm going to leave that blank. So what we're trying to do is find the maximum height of the projectile. And so what we need to know is what is happening at the tippy top of the trajectory. Now, horizontally, this ball is moving 40 meters per second every second, and it never changes. The acceleration horizontally is 0, the velocity never changes. So when it's at the tippy top of its path, it is not stopped. It's moving horizontally. But if you think about its vertical velocity, it goes up, 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 it stops going up, and it starts going back down. So what is true at that point, the thing that we're going to use to solve this problem is that at the maximum height, the velocity final in the y direction is equal to 0. So that's a good thing to put in your toolbox. When you're trying to find the maximum height, you are going to stop your problem when the velocity in the y direction equals 0. So you're going to stop your problem right there. So that is the final state of the problem, not back on the ground. Okay? Once you do that, the second thing you're going to do is you're going to use the y problem to find the maximum height. So you're going to solve the velocity in the y direction final squared equals the velocity in the y direction initial squared plus 2 times the acceleration of the y times delta y. You're going to solve this for delta y because you know the final velocity in the y direction is 0. That's our condition for the maximum height. You know the initial velocity in the y direction. That's how fast it was launched, in this case 30. You know the acceleration in the y direction. You can find delta y. So when I do this, I'm going to get delta y, the distance it goes up from its starting point, is going to equal the velocity in the y direction final squared minus the velocity in the y direction initial squared all over 2 times the acceleration in the y direction, which is negative g. And when I plug all that in, this is 0 squared, this is 30 squared, and it's going to be negative 30 squared, and the negatives are going to cancel, and you're going to get a positive answer, and it's 45.9 meters. Which tells us that for this problem, the ball went up. The maximum distance it went up was 45.9 meters from where it started. Okay? So, since I started at 0, and it goes up 45.9 meters from there, the maximum height is 45.9 meters. Okay, so you're going to use this idea right here within your toolbox to solve the problem when I ask what is the maximum height. Okay? Good deal.